projects. In this video, we are going to explain about the project, which is enhancing medical chatbot accuracy through NGRAM and TF IDF analysis of symptom data. Coming to introduction of the project focuses on enhancing the accuracy of a medical chatbot through advanced text analysis techniques, specifically employing NGRAM and TF IDF, which is term frequency inverse document frequency analysis. The chatbot serves as a virtual medical assistant, providing users with information and guidance on symptoms, potential diagnosis, and recommended actions. Its effectiveness relies on accurately understanding user queries and providing relevant responses. N-gram analysis involves breaking down text into sequences of n-contiguous words, enabling the identification of common patterns and associations within symptom data. By examining these sequences, the chatbot can better understand the context of user inquiries and generate more precise responses. TF-IDF analysis assesses the importance of each term within a corpus of a documents, highlighting terms that are both frequent within specific documents and rare across the entire corpus. Implementing TF-IDF allows the chatbot to prioritize and weigh symptoms and related terms, improving its ability to discern relevant information and provide accurate guidance. The primary objective of this project is to leverage NGRAM and TF-IDF analysis on symptom data to enhance the medical chatbot's accuracy in interpreting user queries, thereby improving the quality of responses and ultimately enhancing user satisfaction and trust in the chatbot's capabilities. Coming to the objective of the project, the objective is to develop a robust medical chatbot that is capable of accurately interpreting user inquiries and providing relevant guidance on symptoms, potential diagnosis, and recommended actions, thereby enhancing user experience and trust in the virtual medical assistants. The goal is to implement advanced text analysis techniques, including NGRAM and TF-IDF analysis, to dissect and prioritize symptom data for enhanced comprehension by the chatbot. The aim is to utilize random forest, NGRAM, random forest TF-IDF, and CNN algorithms to dissect symptom descriptions into N-word sequences, uncover common patterns, and prioritize relevant terms, thereby defining the chatbot's comprehension and response generation capabilities. The objective is to evaluate the performance of the chatbot using key metrics such as accuracy, precision, recall, and FN score to assess its ability to accurately interpret user queries, providing relevant guidance, and effectively assist users in navigating medical information and decisions. Enhance the chatbot's capability to serve as a reliable virtual medical assistant benefiting users seeking quick and accurate guidance on their symptoms, potential diagnosis, and recommended actions, ultimately improving access to healthcare information and empowering individuals to make informed decisions about their health. To implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. In this module, we import essential Python libraries such as pandas for data manipulation, NLTK for natural language processing, scikit-learn for machine learning algorithms, NumPy for numerical operations, and cbond for data visualizations. The next step is exploring the dataset. Here, the dataset containing medical-related text data is loaded and explored to understand its structure, features, and distribution of the data. Coming to visualization, data visualization techniques are applied to gain insights into the dataset, such as frequency distributions of symptoms, potential diagnosis, or other relevant information. The next step is data processing. Here we have removed tokens that contain non-alphabetic characters. This step involves filtering out the tokens that are words in the text data that contain non-alphabetic characters, as they may not be relevant for analysis. We also removed punctuations. Punctuation marks such as commas and exclamation marks are removed from the text data to focus solely on the word's content. We also removed stop words, commonly occurring words with a little semantic value. For example, the, and, is are removed to reduce noise in the dataset. We also limitized each token. Words are limitized to convert them into their base or root form, reducing the complexity of the text data and ensuring consistency in the word representation. Coming to the next step, which is TF IDF vectorization with Ngram. Here, TF IDF, which is term frequency inverse document frequency vectorization, is applied to convert pre-processed text data into numerical feature vectors, considering the importance of the words within documents. Ngram analysis is also performed to capture sequential words patterns. Coming to the next step, which is building the model. This step involves designing the machine learning model architecture. The next step is training the model. The design machine learning model is trained on the pre-processed data and vectorized text data to learn patterns and relationship between symptoms, diagnosis, and actions. The next step is Flask framework with SQLite for sign up and sign in. Here, the Flask web framework is used to develop a web application incorporating SQLite for user authentication functionalities such as sign up and sign in. The next step is user gives input. Here, users interact with the web application by providing input related to their symptoms, medical queries, or the concerns. The next step is the given input is pre-processed for prediction. The user's input is pre-processed using the same techniques applied to the dataset to ensure consistency and compatibility with the trained model. The next step is trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model to predict potential diagnosis, recommended actions, or provide medical guidance. Coming to the last step, which is final outcome is displayed through frontend. The predicted outcome is generated by the model and it is displayed to the user through the front end of the web application, enabling them to access relevant medical information and recommendations. Now we will know what are the algorithms used in the project. So coming to the first algorithm, which is random forest Ngram, it refers to a variant of the random forest algorithm that incorporates Ngram analysis. Random forest is a versatile ensemble learning algorithm used for both classification and regression tasks in machine learning. It constructs multiple decision trees during training, each trained on the random subset of the data and features, and combines their output through voting for classification or averaging for regression to make predictions. Random forest is chosen for its robustness, ability to handle high dimensional data, and resistance to overfitting, making it suitable for improving the accuracy of medical chatbot in this project. Coming to n-grams, n-grams are continuous sequences of n items from a given sample of the text or speech. In this context, n-grams are the sequences of n words. For example, in the phrase of the quick brown fox, the 2 grams or the bigrams would be the quick brown, and the brown fox. The project utilizes random forest and ensemble learning method along with n-gram analysis to process text data representing as n-word sequences. This combination leverages random forest robustness in handling high-dimensional data and n-gram analysis ability to identify patterns in symptoms, descriptions, enhancing the chatbot accuracy in understanding user inquiries and providing precise responses. The next model is random forest TF IDF. It refers to a variant of random forest algorithm that incorporates term frequency inverse document frequency analysis, which is TF IDF. TF IDF is a statistical measure used to evaluate the importance of a term within a document corpus. It considers both frequency of a term within a document, which is term frequency, and the rarity of the term across the entire corpus, which is inverse document frequency. In this context, random forest TF-IDF involves using random forest in conjunction with TF-IDF analysis to prioritize symptom terms and enhance the chatbot's ability to provide accurate guidance. This combination allows the algorithm to weigh the importance of symptoms and terms within user inquiries, ultimately improving the chatbot's comprehension and response generation capabilities. The last algorithm is CNN. CNN stands for Convolutional Neural Network, which is a deep learning algorithm commonly used for image recognition and classification tasks. However, it can be applied to text data through techniques such as word embeddings and 1D convolutions. In the context of this project, CNN refers to utilization of convolutional neural networks for text analysis. This involves treating text data as a sequence of tokens that are words or characters and using convolutional layers to extract features from these sequences. CNNs can capture patterns and relationships within the text data, enabling chatbot to better understand and respond to user inquiries. By incorporating CNNs into the project, The chatbot can benefit from their ability to capture hierarchical patterns in the text data, potentially leading to improved accuracy and performance in understanding and generating responses to user queries related to medical symptoms and diagnosis. We have used accuracy, precision, recall, and FN score, which are the performance metrics, to evaluate all the classification models built in the project. So here we have performance comparison graphs for all those metrics. This is accuracy comparison graph. Here in the graph, on x-axis, it represents all the algorithm names and y-axis represents accuracy score. Similarly, we will have for other graphs also. Now we will know what is this metric accuracy. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. This is precision score comparison graph. It is the ratio of true positive predictions to the total positive predictions, representing model's ability to correctly identify relevant instances while minimizing false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. This is FN score comparison graph. FN score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced dataset. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder in which we have the dataset. We use the dataset for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And these are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is a database file which is used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Here, using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can observe that current directory is changed to the code folder's path. Now we need to type the command python space app.py to compile app.py file. And now click on enter. This will execute a Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host, and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flask framework. To execute the project, first we need to sign up. For that, click on sign up link. Here we need to enter all these registration details if we are registering newly. I have registered already and I have an account already, so I'll directly log in. For that, click on sign in. Here we need to provide our credentials to sign in. So I'm giving my username and the password. And now we have to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a medical chatbot, and this is a text box where we have to enter the symptom of the disease. In the notepad, we have some of the test cases using which we are going to do the prediction. So I'm copying the first test case. So here I'm copying it, which is the itching skin as a symptom of the disease. Click here to predict the disease. This is the message which we have entered. and the chatbot has predicted for the symptom as chronic cholestasis. Here is the diet plan for the disease which has been recommended by the chatbot. Additionally, here we have the doctor prescription. This is the doctor and this is the prescription which is given by the doctor. Now we will try with the other test case. I'm copying the last one, which is nausea, loss of appetite. Get back to the web application. Here I'm pasting the symptom. Click here to predict the disease. So here, based on the given symptom, chatbot has predicted the disease as hepatitis C, and this is the diet plan recommended by the chatbot. And it has given doctor prescription. Here is the doctor, and this is the antiviral medications prescribed by the doctor. Now we will try with the other test case. I'm copying the watering from eyes. Get back to the web application. Paste the symptom here. Click here to predict the disease. This is the symptom which has been entered by us. And here is the chatbot's prediction of the disease as allergy. And this is the diet plan given by the chatbot. And here we have the medication prescribed by the doctor. Now click on log out. In this way, just by giving the symptom of the disease, chatbot will give the disease prediction and the diet plan and also the medication prescribed by the doctor. Coming to the conclusion of the project successfully developed a robust medical chatbot leveraging advanced text analysis techniques including Ngram and TF IDF analysis integrated with machine learning algorithms such as random forest and CNN. Through extensive data exploration, visualization, and pre-processing, the chatbot was equipped to accurately interpret user inquiries, provide relevant guidance on symptoms, potential diagnosis, and recommended actions, thereby enhancing user experience and trust in virtual medical assistance. The incorporation of Flask framework with SQLite for user authentication streamlined the user interaction process, enabling seamless sign-up and sign-in functionalities within the web application interface. By training the model and pre-processed and vectorized data, the chatbot demonstrated proficiency in predicting medical outcomes and offering tailored recommendations, contributing to improved access to healthcare information and informed decision-making for users. Overall, the project's success in developing an efficient and user-friendly medical chatbot underscores the significance of leveraging advanced text analysis and machine learning techniques to enhance virtual medical assistance, ultimately benefiting individuals seeking prompt and accurate medical guidance in their healthcare journey.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.